Hello class, and thank you for watching. In this video 3.2 titled Domain and Range, we're going to start by first reviewing the interval notation. Now recall that when it comes to using interval notation, that the smaller number in the interval is always written first and the larger number is written second following a comma. Now we use parentheses or brackets depending on whether we want to include or exclude the endpoints. Parentheses are used when we're excluding the endpoints, and we use brackets when we're going to include the endpoints. So let's look at several ways of using inequalities and how they correspond to interval notation and a number line. So the first one I have right here is greater than. This right here states that x is greater than the value of a. As an interval notation, that means that a is going to be the smallest possible value, so a would go first, and the largest possible value would be positive infinity. Since a is not included as the solution set in this interval, we're going to indicate that by using parentheses. And obviously infinity, we always use parentheses with infinity because infinity is never included, because we never actually reach that. Now as a number line, this concept that the value of x is going to be strictly greater than a and not equal to a is indicated by having an open circle over a, and all of our x values being greater would be to the right of that value, again going towards positive infinity. Now if x is going to be less than a, then our interval notation is typically written backwards. A is the biggest value in the solution set, so all our values will go from negative infinity until we reach a. And again, we're excluding a, so we're going to use a parenthesis to indicate that. Our number line will simply be backwards, like this. Even though the arrow is indicating again that we're going towards negative infinity from a, the concept, however, is that we're starting from left to right, so negative infinity until we get to a. All right, so don't be fooled when looking at number lines of how the arrow correlates again to the interval notation. Notice that it's always from left to right, negative infinity first, the a second, even though this ray is pointing down that direction. Okay, I know in geometry we see things like that, and the ray pointing in a direction, meaning that this is the first point that we use and this would be the second point that we use in naming the ray, but that's not the same thing that's going on right here when it comes to interval notation. Now the difference between the first two and the second two is that we're now going to include the endpoint of a. Like on the first one, we said that x was greater than a. This one we're going to say that x is not only greater than a, it could also equal to a. So we're now going to include the endpoint. So to indicate that, we're going to use a bracket on the end where a is located and a parenthesis where infinity is. And on the one after that, to say that x is less than or equal to a, we'll simply put the order of the interval the same way as this, but put bracket at the endpoint of a. Now the respective number lines look the same as the top two for each individual one, with the only difference is that they're going to be closed circles this time to indicate that the endpoint is included. Now we can also equal to a. Now, let's say that we're not only going to be greater than or less than one particular value, but we're going to be between two values, two endpoints. Okay, now we're not going to go beyond to negative or positive infinity. Like in this example right here. From left and right, this is understood to say that a is less than x and x is less than a. In very simple terms, this notation simply is indicating that our solution set is between the values of a and b. And because there is no equal sign, that means we're excluding those two endpoints. So the values for x will be any number between the endpoints of a and b. And since we're strictly between the value of a and b and not including any of them, we're going to use, again, open parentheses to indicate that. And with a number line, a first, b second, we use open circles to indicate that concept. Now in the second one, not only is x between the values of a and b, but it's also going to include the value of a, and the reason for that is because of the equal sign. So as an interval, the order stays the same as the top one, but at the endpoint of a, since it's included in the solution set, we'll use a bracket instead of a parentheses. And as a number line, that will look like this. Again, a and b from left to right. So all our solutions are then values between, again, these 2 points. So everything in between there. But this time we're including the value of a as part of the solution. And then we could do it backwards. Instead of including the first point, the starting point, we could include the last point. Like as you see right here, we're including now the endpoint of b. So this just simply switches the bracket parentheses, which switches the open and closed circle on our number line. And on the this next one, notice that we're including both a and b. Okay, this notation means we're including both a and b, because not only is a less than or equal to x, but x is going to be less than or equal to b. So a and b are included. So that just simply puts brackets on both of them. And here is your number line. Now the next one is a compound inequality, but before I do that one, let's talk about the last one. The last one is all real numbers. All real numbers is indicated that we're using every number on the number line. So from negative to positive infinity, which is just your entire number line, negative to positive infinity. Sorry, let me go back. Here we go. Okay. So all real numbers fall in there. Now, the reason I wanted to go that one first, because the next one is all real numbers except, so we're excluding the value of a. So if we're going to include all real numbers, that will look like this: negative infinity, positive infinity. But since we're going to exclude the value of a, that means that there would have to be a point in this value from negative to positive infinity where there's going to be an open circle. So all the values to the right and all the values to the left, except for that one value somewhere between negative and positive infinity. As an interval notation, to indicate that we're going to exclude this one point from negative to positive infinity, we would have to use a disjoint interval. So let me zoom in so I could write it well. It would look like this. It would look like negative infinity to a, or all the values of a to positive infinity. Which brings up the fact that stating that x cannot equal to a, let's write this down, that our values are going to be that x is going to be less than a, or x will be greater than a. So that's another way of using set builder notation inequalities to indicate that x cannot equal to a, by using the disjunction word of or. Okay. So this is the first part on using interval notation. And on the next video, I'll go over how we use this interval notation to determine the domain and range of a relation using a graph.